video, we are going to talk about distributed computing, and we'll see what distributed computing is. Then we'll see the benefits of it. Then we'll see the key component present in distributed computing, and then we'll see various architecture being used for this. So first, let's see what it is. Distributed computing is a method of making multiple computers work together to solve a common problem. Each device in distributed computing has its own processing capability and may also has its own data store and manage its own data. You can imagine this as a system of software components spread over different computers but running as a single entity. These devices work together to perform tasks and share resources with each other. And there is no single device which act as a central hub. So there are multiple devices, they connect with each other, they share resources to perform a specific task. So benefits, what are the benefits of this? So first is scalability. The distributed system can be easily scaled by adding more machines whenever needed. The second benefit is fault tolerance. Your distributed system will not crash even if one of the computer goes down. So this design ensures that system will continue to operate even if one of the individual computers fail. So the next benefit is transparency. Distributed system provide logical separation between user and physical device. You can interact with the system as it was a single computer without worrying about setup and configuration of individual machine. You can have different hardware, software, and operating system that work together to make your system function smoothly. The next benefit is efficiency. Distributed system offers faster performance with the optimum resource usage for underlying hardware. As a result, you can manage any workload without worrying about the system failure. Now let us see the key component in the distributed system. First is primary system controller. This is the only controller in the distributed system. It is responsible for controlling the dispatch and management of the server request throughout the system. The executive and mailbox services are installed automatically on primary system controller. The next component is secondary controller. It is a process controller or a communication controller. It is responsible for regulating the flow of server processing requests and managing the system translation load. It also governs the communication between system and virtual area network or trading partners. Next component is user interface client. This is an additional element in the system that provides user with the important system information. This is the not part of clustered environment and it does not operate on the same machine as a controller. It provides functions that are necessary to monitor and control the system. So basically, it allows user to monitor and control the system using this user interface. So after this, the next component is data store, system data store. Each system has only one data store for all its shared data. The data store is usually present on disk vault, even if it's clustered or non-clustered. For non-clustered system, this can be even a single machine or a distributed across several devices. But all of these computers must have access to this data store. The last component is your database. In database, relational database stores all the data, and once the data store locates the data, it shares it among multiple users. Relational database can be found in all the data system and allow multiple users to share common information simultaneously. Now let us look out for various architecture being used for distributed computing. So we have basically two categories of architecture. First is the software architecture. So software architecture is basically logical organization of the software component and the interaction with other softwares, and it is a low level design than a system architecture and focus entirely on the components of the software. So we have like layered architecture in this type of architecture separates the component into unit. Your request goes from top to down and the response goes from bottom to top. The advantage of this layered architecture is that it keeps things orderly and modify each layer independently without affecting the rest of the system. The next software architecture we have is the data or centered architecture. So in data centered architecture, before let's talk about object-based architecture. Yeah. So object-based architecture centers around an arrangement of loosely coupled object with no specific architecture like layers. So unlike the previous layered architecture, it does not have to follow any steps in any sequence. Each component is an object, and all the objects can interact through an interface. Under object-based architecture, such interactions can happen through a direct method call. Now let us see the data-centered architecture. So it works on the central data repository, either active or passive. Like most of the producer-consumer scenarios, the producer produces the item to the common data store, and the consumer can request the data from this data store. Sometimes the central repository can be just a simple database, but all the communication between the object happens through this data store, stored in the central data system. And it supports the storage components with the persistent storage such as SQL databases and system store all the nodes in this data storage. So after this, we have event-based architecture. So in this, entire communication is through the events. When an event occurs, system gets a notification. This means anyone who receives the event will also be notified and has access to that information. Sometimes these events are data, sometimes it's URL to the resource. As such, a receiver can process what information they receive and act accordingly. One of the significant advantage of event-based architecture is that components are very loosely coupled. Eventually, it means that it's easy to add, remove, or modify them. Now let's talk about the system architecture. So it focuses on the entire system and placement of component in the distributed system across multiple machines. So there are two common system architecture. One is client-server architecture, and then is a peer-to-peer architecture. So in client server architecture, as the name suggests, we have a client, we have a server. A server is where all the work processes are done, while the client is where user interacts with the service and other resources. So client requests something from the server and server will respond accordingly. And client server architecture has a standard design feature called centralized security. So data such as username or password are stored in secure database for any server user to have access to this information. This makes it more stable and secure than peer to peer architecture. The disadvantage of this is the single point failure. Now let us see the peer-to-peer architecture. So peer-to-peer architecture is works on the concept that no central control in a data distributed system. A node can either act as a client or a server at a given time once it joins the network. A node that requests something is called a client. The node which provides something is called a server. In general, no each node is just a peer. So if a new node wishes to provide services, it can do so in two ways. One way is to register with a centralized lookup service which will then direct the node to a service provider. The other way of the node to broadcast the service request to other nodes in a network, and whichever node responds to will provide the requested service. So P2P networks of today have three separate sections. First is structured P2P. The nodes in a structured P2P follow a predefined distributed data structure. There is unstructured P2P. So P2P is just basically peer to peer. So in unstructured P2P, we have the nodes in unstructured P2P randomly select their neighbors. And there is a hybrid P2P. In hybrid P2P, some nodes have unique function appointed to them in orderly manner. So this was all about the distributed system where we see like what it is, what are the benefits, what are the key component, and this was the most important part, like what are the architecture. So there are system architecture, software architecture. So this was all for this video. Thank you and have a nice day. Bye.